Music versus noise. Musical sounds are characterized as periodic waves, which repeats regularly, whereas noise is characterized as a periodic wave, which has no repeating pattern. So, musical sound is usually explained by smoothness of tones, where noise was produced by non-periodic wave without any smoothness, which is characterized by irregularity and roughness. But in reality, there are no clear distinction between music and noise. Some noise have musical characteristics, and some music has noise characteristics as well. What are the properties of musical event? Musical event can be described by four properties, describing subjectively or objectively: pitch or frequency, volume or the amplitude, timbre, overtone or the quality, duration in beats, which is the duration in time. Frequency or the pitch is measured in cycles per second or hertz unit. So in 1 second we have two wave, frequency is 2 hertz, and the wavelength is the distance between corresponding points on the wave, which is the inverse of frequency. Wavelength is given by c by frequency. And audible frequency range of humans is 20 hertz to 20,000 hertz, or 50 feet to 0.05 feet. That is, they can much larger than the wavelength of light used. That's why we can hear from around the corners, but we can't see around the corners. Usually our pitch perspection is logarithmic. That is, we don't, or our ear don't recognize between equal and absolute value of sound, rather the relative difference between sound. That's why we use logarithmic scale to explain the pitch or the perception in the case of sound waves. For example, we hear an equivalent pitch class with every doubling of frequency. That is, distinction between two frequency classes, two pitch classes is if it takes 55 Hz and then 110 Hz. So it's very difficult to distinguish between close frequencies or absolute value of frequencies. That's why frequencies of octaves are used in concerts, because it's very easier to distinguish between the frequency range in between each octaves. Intensity of sound is the sound power per unit area, or is the amount of sound energy incident on unit area, which is held normal to the direction of the wave in 1 second. This is proportional to the square of the amplitude given by I equal 1 by 2 rho 0 b omega square a square. Rho 0 is the mean density of the medium, b is the velocity of the wave, omega is the angular frequency, a is the amplitude. The unit of intensity is watts per meter square. And the minimum intensity that can perceived by human ear is I0, is the threshold hearing intensity. At 1000 Hz, I0 is 10 raised to minus 12 watts per meter square. And the corresponding threshold pressure is 1 billionth of atmospheric pressure value. And the threshold of pain intensity, which is a maximum intensity which can be and which our ears can go underway, is 10 raised to 12 I0 equal to 1 watt per meter square. So human ear range, audible range is I0 10 raised to minus 12 watts per meter square to 1 watts per meter square. So ear sensitivity ranges from I0 to 10 raised to 12 I0. Loudness of sound is the degree of sensation of sound, depending on the intensity of the sound wave generated as well as the sensitivity of the ear. Human ear sensitivity from I0 to 10 raised to 12 I0. So we use logarithmic scale as our ear perceives relative loudness rather than the absolute value of loudness. So the unit used is in the logarithmic scale is bell or decibel. So if I is the intensity of the given sound and I0 is the threshold limit, then the ratio of sound intensity level beta is given by logarithm of I by I0 of bell unit, or 10 log I by I0 in decibel unit. As intensity is proportional to square of the sound pressure, ratio of sound pressure level is given by 20 log P by P0 in decibel unit. So 1 decibel is the just noticeable or the minimum noticeable difference between sound levels. So our range of human hearings can be explained as 0 to 120 decibel or 0 to 12 bell. These are examples of a sound level. A soft rustling leaves has a decibel value of 10 decibel. Normal conversation usually 16 decibel. Construction level can go up to 110 decibel. And threshold of pain, the maximum threshold of noise level can be 125 decibel. For example, we take whisper and I equal to 10 raised to minus 9 watts per meter square. Substituting the value of I 10 raised to minus 9, beta equal to 10 log I by I0, that is beta by 10 equal to log 10 raised to 3, or 10 raised to beta by 10 equal to 10 raised to 3, that is beta by 10 equal to 3 or beta equal to 30 decibel. A different example, jet plane has a 150 decibel value. So beta 10 log I by I0 equal to 150 decibel or I by I0 equal to 10 raised to 15. I equal 10 raised to minus 9 into 10 raised to 15 equal to 10 raised to 3 watts per meter square. Sorry, 10 raised to minus 12. So pain threshold is 1 watts per meter square hour. That is continued exposure to a jet plane noise will be harmful to our ears. Timbre. So suppose we are in a concert and we are hearing sound from different musical instruments. So suppose the two musical sound has same pitch as well as same amplitude. Then how do we recognize or distinguish between these two sounds? So this is done by using the timbre or the quality of the sound. So timbre can be explained in a different way. So consider the behavior of wave in a bounded medium, that is a string secured at both ends. And when we pluck the string once, we initiate the wave motion. This is the string's maximum deviation. And the wavelength is twice the length of the string, and the perceived frequency is fundamental frequency. But along with the fundamental frequency, we will have a collection of frequencies generating. That is a collection of waves generating. And the only waves, that is the frequencies, that is integer multiplication multipliers or subdivisions of the fundamental frequency will be propagating, all others will be cancelling each other out. These are called the overtones. So this overtones or harmonics will be generated along with the fundamental frequencies value. So the first six harmonics are usually the strongest, which are here denoted by fundamental octave, with octave, major third, etc. in the case of a concert. So we can distinguish between the fundamental and the other harmonics value or the overtone value. So this represents the timbre of sound waves.